Okay, we're on question number 6, and I'm seeing the natural log of 1 plus x. And again, the center's still at 0. Again, I'm thinking it might be something to do with a geometric. And let me write this over here for you. So f of x is equal to the natural log of 1 plus x. And I want to look at the geometric series. And the geometric series is this one over here, which is 1 minus x, which is going to be 1 plus x squared plus yada, yada, yada. But I could also write this one down over here. Whoops. I can write down 1 plus x. 1 plus x. What's that going to be? 1 minus x, whoops, not minus, but plus x squared minus x cubed, yada, yada, yada. I'm going to integrate that guy. And what would you get? You get the natural log. I'm integrating both sides, by the way. 1 plus x plus some constant of integration, by the way. Now, whether you put it in the left or right doesn't matter. You got to put it somewhere. What's the antiderivative of the right side? Let's see. X minus x squared over 2. And then it's going to be plus x cubed over 3. And then minus x4 over 4, yada, yada, yada. I need to figure out the c. And what you need to do is pick an x to figure it out. And the easiest x for me to pick would be x equals 0. And what do you get over there? The natural log of 1 plus c. And if you put an x on the right-hand side, it's just 0. What's natural log of 1? It's 0. So c must be 0. All right? Because 0 plus 0 is 0. So now I know this. I know the natural log of 1 plus x is equal to this over here. And let's write that down. That's going to be the sum. I'm going to start at 1. Now let's start at 0. N equals 0, off to infinity. Let's see, it looks like minus 1 to the n, because then I get plus minus, plus minus, plus minus. It's going to be x to the n plus 1. There will be a divisor, and what's the divisor going to be? Looks like n plus 1. All right. Now, realize the radius is pretty easy to put down, by the way, because we just did it from the geometric. The thing about integration, though, that, although the x, because I did use a geometric series, is this over here, when you integrate, you might gain an endpoint. So I got to test this out. And where do you test it out? In the series. All right? So what series are we talking about? This series. Let's try the 1 first. And let's see what happens at 1. And if I do that, the series at 1, this is n equals 0 to infinity, would be minus 1 to the n. And now x is 1, by the way. What do you have here? N plus 1. Well, this is an alternating series that converges, so I include that. Let's do the bottom one. What do you get over there? This would be n equals 0, off to infinity. A little more complicated. Minus 1 to the n, and then minus 1 to the n plus 1, all over n plus 1. Well, a little complicated, isn't it? N equals 0, off to infinity. What would the top give you? Minus 1 to the 2n plus 1, n plus 1. This is not an alternating series, by the way. It's always going to be a negative term series. It's harmonic. So what do we know about this over diverges? So my interval, we gained an endpoint, by the way. It goes from minus 1. Let me write the I down for you. So the I goes from minus 1, but we gained the 1 in the end. All right? Let's look at the answer key, make sure we got all the stuff written down for you. And this is question number 6 now. And do I have number 6 written down? I do. And I'm looking at it, and I do see this. I see that business over there. I see r equals 1, and I see the I. And I do see that gained the endpoint over there. Things are looking as advertised. Thank you.